Welcome everyone to my presentation, The Fuzzy Line Between End-to-End and Component Tests. I'm Gleb Bakhmutov and I thank the organizers of the QA Global Summit for giving me a chance to describe my experience with Cypress component testing. The presentation is online, is available at this URL. I'm gonna cover end-to-end tests and their shortcomings, and then I'll show how component testing can complement end-to-end testing and has a lot in common with end-to-end tests. I'm Gleb Bakhmutov. I had a long journey from C++ and computer vision through CoffeeScript to Node.js and finally the front end. I've been posting videos and advice on how to write end-to-end tests for a while now, and you can find everything online on my personal site or on GitHub. I started a website called Cypress.tips where I put links to the courses I make. They're mostly about Cypress and how to write Cypress end-to-end testing. I'm a member of a couple of climate organizations trying to fight the climate crisis. I encourage you to join me. During day-to-day, I work at Mercari US. It's an online marketplace, and I'm in charge of automated web application testing. We actually write a lot of tests, and I share our experience and our tips for writing end-to-end tests and running them through my presentations. And you can find a couple of slide decks at slides.com/Bakhmutov. For this presentation, I decided to take a game of Sudoku. Everyone has played this game. You just have to fill the empty squares with numbers so that every row and every column and every 3x3 square has unique numbers from 1 to 9. You can find the code and the tests I'm about to show at GitHub at this particular repository. Let's start by testing the game modes. You can play this game in easy, medium, and hard modes. So how would you test it? Well, I would install Cypress, and it's a simple npm dependency, npm install Cypress. I would start the application, so it starts running at localhost 3000, and I would open Cypress using Cypress open command. Once Cypress opens, you would see something like this. It's a dialog that allows you to select the type of a test you want to run. For this particular first test, I only have written end-to-end test, so you will see end-to-end testing is configured. We're going to get to component tests later. In my Cypress config file, I set the local base URL because I don't want to hardcode the localhost 3000 in my spec files, and I might have deployed the application somewhere else, so later I can test that particular deployment. For now, the application is running at localhost. Here's my spec file. And for modes, the most important thing is to check how many cells I filled at the start of the game, because in hard mode, you leave more cells empty. So we're going to start by visiting the URL, which will be the base URL. We're going to check that the value of that select dropdown is easy, and we're going to see how many filled cells there are. There should be 45 cells. And if we change the game setting to medium, the game restarts, and now we're checking that we only have 40 cells filled. The game became a little bit harder. And if we change the difficulty level to hard, well, then there should be only 30 cells filled. And this is how the test looks when Cypress runs. You can see every command on the left. You can see the test on the right. And you can see how the application will look at each step if you hover over each command, and in this case, how many cells were filled for each mode. With time-traveling debugger and having the application on the right side is great, because you can literally see how the human user sees the game during the test. Now, how do we actually test the gameplay though? Right? We tested just the difficulty. Can we play the game? And here's where we are hitting the difficulties. It's very hard to control the randomness. Our game board is generated randomly inside our application code. We cannot set particular game board easily from end-to-end test. Now, there's one way where we can control it, kind of. We can click the hint button to fill the cell that's currently empty and has the focus. So we can write an end-to-end test that fills every empty cell by clicking the hint button. We again visit the URL. We have 45 fill cells. And then we get all the cells and we filter out the fill cells so we have only the empty cell elements. And then we take each cell page element, we click on it, which looks like this. We click on a cell, it gets focus, and then we click on the hint button. Click and click on each empty cell, alternating with the hint button. And then we check that we solve the whole game, because if we click on every empty cell and fill it with a hint and it's correct, then we should have solved the Sudoku game. Let's see how the video of the test running looks. Notice we're filling every empty cell really quickly, and then at the end we filled the whole board and the overlay shows you solved it, and we can observe the last cells being filled. Now, this is difficult, right? It's not a true solution. Anytime you have random data, that makes writing an end-to-end test more difficult. Anytime the server can respond with the data you don't control, that makes writing end-to-end tests difficult. Anytime you have timers, clocks, timestamps, those things make end-to-end test writing hard. Anytime you have to do conditional testing, where you look at the page and then you change the test command depending what you see, well, that makes the testing difficult. Finally, if it's unclear what you're testing, what the expected output, what to expect to see on the page, well, those cases make end-to-end testing hard. So, for example, let's look at this timer. It just shows how many seconds, minutes, or hours really passed since the start of a game. The shorter amount of time you take to solve Sudoku, the better. So how would you test the timer element? Well, you can write an end-to-end test. In this case, you visit the page and you check from 1 to 10 that it shows second 1, 2, and so on, formatted using sci-contains command. This is how the test looks. You can see how each command pauses until the timer updates. It uses built-in Cypress retriability that keeps searching the page for the text. While we waited only 10 seconds, can we confirm that the timer is showing 15-minute interval correctly? We could potentially wait 15 minutes. But of course nobody wants to wait 15 minutes for the test to pass. But there must be a better way, I believe, to test this. Let's go back and think how we would write not end-to-end test, but a test that tests a smaller piece of code, like a function. This is how our timer formats the code. It uses format time. If we had to test this function that we can import from the timer source file, we could write what we would consider a unit test. We would call format with different inputs, and we would confirm that the string it returns is what we expected to have. For example, if we pass seconds 3, we expect that function to return 00:03. Cypress can run this test. You don't have anything on the page, but you do see the output of each chai assertion. So let's go back to our timer component, not a function, but the component. What I really want from my test is not a unit test, but something where I can import the timer component from the source file and then mount it somehow using JSX, pass the prop, and then confirm using Cypress command that it shows 15:00. This is what I want. I want to see the component because ultimately that represents something on the page. And so now the test is not site-visit. It's something else. We want to write a test in Cypress that understands framework-specific, like in my case, a React-specific component timer. We want Cypress to know how to bundle that component and how to run it on the page. We're no longer using sci-visit the page. Instead, we'll work with a per component bundle inside the spec file. So this is where Cypress component comes into place. Instead of starting the application, localhost 3000 and so on, we're going to just open Cypress. The application is not running, but we can select the component testing. And if you are doing this for the very first time in your app, it would ask you, are you using this framework? And it would actually try detecting the framework automatically. In addition to React and Create React App, you can pick one of the modern frameworks like Angular, Svelte, or Vue. This writes in your config file the framework that we detected and the bundler that Cypress should use with that component. Now you can write a Cypress component test, and it contains the main parts. It contains the component itself. It might need React so it understands how to actually bundle the timer. It imports the CSS, so each component can import its own CSS styles. You can import additional React, let's say, context objects, and you can import additional third-party libraries. You use a SciMount component command. This command is specific to a particular framework and library, and this is something that was configured when you select the framework. And you mount, in this case, a React component just like you would use it from the application by passing props. And then you use Cypress scicontains command to verify that on the page, that component, when it starts running, it shows the text 15:00. And this is how the test looks. And it's a live application. You can open the DevTools and see the component actually updating itself because there is a set interval that updates every second the displayed value. You can use all Cypress time traveling capabilities, the DevTools, everything. The test is much faster than end-to-end. Well, because component is much simpler, it only needs bundling, you don't have to visit the URL at all. The most important thing is that you see the component live. You're no longer using something like just DOM running in Node. Instead, you have a real browser with full browser APIs and the component running as a mini web application. If you look at the parts of the spec, Cypress now understands how to bundle your framework correctly. It understands how to import global CSS just like your app would, right? And how to make the styles apply by, surrounding your component with additional markup. In this case, if you don't include app CSS or if you don't apply the markup, well, you would still see the text. It just doesn't look like the component in the real application. But if you import app CSS globals and the styling is correctly applied through the structure, then you see the actual timer like you would in real application. You can pass data to your component by using both props and React-specific structures like context providers. If you look at the application, we build the modern UIs through components. Even in our simple game, we have individual components like status, timer, the numbers, the game sections. All of them are coming together as a game component. Finally, it's mounted and run by the app component. So there is a hierarchy of components. We can pass data, like I said, using props, and we can even test, for example, our numbers component where the user clicks on individual numbers by passing Cypress stub as a property. Once the component is mounted, we passed all the data, it starts running, and then it's a web application. The best thing about component testing is that you use normal Cypress commands. Here's the test. It mounts the component, it confirms that the selected number shown is 8, and then it clicks on number 9 and confirms that a property callback was passed correctly. And if you ask me, how does this compare to other testing tools? For example, in React, I would follow Murat Özkan. He recently put together an ebook comparing Cypress component testing to all sorts of other testing solutions for React specifically. He has a huge number of Cypress tests and matching React testing library tests, so you can make a judgment for yourself. He even looked around and he picked all sorts of React testing examples from different books, tutorials, articles, and wrote corresponding Cypress component tests. The best thing for me is not React testing specifically. If you look at the framework testing examples that, let's say, React docs have, if you write the corresponding Cypress test, it doesn't have much React-specific commands, because majority of cases are covered by the Cypress API already. So all you have to do is the mount component, pass the props to control its data and behavior, and then use Cypress commands, for example, to interact with that component and validate the output through the DOM, through network commands, cookies, you name it. For example, in this case, you can kind of see that we never have to remember how does React testing library or enzyme pass events or control asynchronous behavior. We just click and it works. Again, mounting of component is framework specific. Then you use Cypress commands to interact with the component running. In this case, we create a component and pass a login service, and then we click on sign in and validate what the component is showing. You can see that what we passed as stubs and spies has been called. We can see the navigation component. And if I ask you, like, what's the framework here? Is it React, Svelte, Vue, Angular, or anything else? You don't really cannot tell, right? Because these look like normal objects and just mount command. In this case, it's Angular. And I actually took this example and wrote this Cypress component test by looking at the examples written using Angular test harness. Test harness is specifically for Angular project. It replaces some of the boilerplate code. It doesn't really make it that much shorter. But an equivalent Cypress component test, because it uses built-in Cypress API commands, is much shorter and easier to remember. And anyone who is experienced with Cypress component testing on a React app, for example, can easily understand and maintain this particular component test for Angular. Cypress team has a bunch of examples of component testing for different frameworks and languages and frameworks, so just check it out. Okay, so back to our application. Like I said, small components are merged into larger components that are used by the game component, which ultimately is used by the app component to start writing or running on the page. So why don't we test the game component itself, one of the bigger components? Well, we have to set up the data, and in this case, we can pass the initial array and the solved array. These are just two JSON files that I saved. Now remember, random data has presented a problem for end-to-end testing. Well, when you do component testing, you can pass it as props, in my case. Then we can find all the empty cells, and we iterate over those 3 empty cells. In my case, the initial array only has first 3 cells empty. And then I can fill them with values from the solved array. I no longer have to rely on the hint button. I can look up each number and click on it and confirm that the overlay solved is displayed. So this is this test slowed down a little bit. So it takes about 2 seconds. My test confirms that the overlay you solved is displayed. It looks like a normal test, right? Only you don't see the URL because there is no URL to visit with testing that React game component. Now, there's one thing that you might ask me, what is that 4 of 4 at the end of a test? Well, the overlay component at the end fetches data, and it fetches the data for the durations that it took me to solve that particular game. Now, because it took 2 seconds, it fetches /time/2. It looks up best scores pretty much. We can write a component test, and instead of trying to stub a fetch or Ajax or some kind of library that actually makes the network call, we can use built-in Cypress network intercept command. For example, we can say whenever the component is making a network call to times/90, which is 90 seconds, delay the response and return 404. So we're testing how the component handles, a network error. When we mount the component and we continue interacting with the component like a normal, end-to-end test would. Only instead of end-to-end, we wrote a component. And this is how it looks. So after 2 seconds, the loading goes away and our component just keeps showing you solved it. It doesn't show any errors, nothing. Now we can return a fixture with some scores or durations instead of an error. And in this case, we can confirm that our overlay shows that the 90 seconds is our current result. And this is how the test behaves, and component shows a minute 30, 90 seconds in pink. Perfect. We tested how component fetches data from the backend, even if we didn't have a backend yet ready. So my advice is to mark not other pieces of your code when you test the component, but instead mark at the periphery of a browser. Mark how the component ultimately fetches data or stores the data or retrieves the data. And it's still okay to pass spies and stubs through props. Well, if we go back to end-to-end test, we can do another trick to control the random data. In my application, I can specifically check if window has starting and solved properties and assume these are the arrays I want to play instead of generating random data. I can then listen to the data going through the network. So I can use the same spying and stubbing or using Cyintercept like I did in my component test, and then I can play the game and confirm that the results are shown. This is my end-to-end test that now runs at localhost 3000 and confirms that the score, the timing, has been shown. The same test can be written like I've shown before as a component test. Only instead of visiting, we literally can set the props. Which one should you use? Ultimately, think about what the test is doing. I've shown unit, component, and end-to-end tests in Cypress. Unit tests are for small pieces of code like function, class. Component test is for framework-specific components that ultimately will be shown in the browser and run as parts of your application. End-to-end is testing the full running web application that has a URL to visit. The component testing makes it so much easier to pass data that is hard to control from end-to-end test. Maybe edge conditions, maybe something related to timing or random generated data, and the end-to-end component test can easily test it. End-to-end test, on the other hand, makes it so much easier to test the entire user flow, usually through a happy path and maybe some edge conditions. The Cypress team had put a little guide kind of summarizing the differences and common things between component testing and end-to-end testing using Cypress. If I can summarize my own things, why I would actually write Cypress component test, it puts testability of your web application code front and center. If you can write a good component test, it will make it easier to write a good end-to-end test. You use the same API to interact with a component as you would with end-to-end test, which is great because you learn it once and you apply it in all sorts of tests. And finally, you run your component test in the full browser. It means you don't have to mark anything. You don't have to rely on just DOM APIs, and you can see each step of your component test as it gets executed. You can use the DevTools. You can inspect everything. You can inspect the network tab. You can understand what's going on. Thank you for listening to me. I'm Gleb Bakhmutov. If you have any questions regarding my talk, feel free to reach out. The slides are public, and thank you for your attention and have a great rest of your day.